Okay, so the midterm I sent you, we will start with the first question, question number 1. So in a recent study of 100 marriages identified from announcement local newspaper, they sampled them and they sent them a questionnaire. 62 replied. From this number, there was 49 women married for the first time with an average age of 22.5, standard deviation 4.2. Okay. Calculate the standard error for the sample. Standard error is basically the standard deviation over the square root of n. So standard deviation is 4.2 square root of n, and your n is the 49 women. So it would be 0.6. From your text, find the t-star value at 99 confidence interval for all women. So first of all, to find t-star, we need degrees of freedom. And this is one sample only, so it would be n minus 1, 49 minus 1, 48. And it's at 99% confidence interval. So you use the t-table provided for you. I don't have access to that t-table, so I can Google it from the internet. Just any t-table would do. There is, when you Google, there is a blue t-table that I like. So you go down to the degree freedom 48. You don't see 48, so you use the closest. You could use the 50 or the 40. And it's 2.66, 2. So maybe you guys have a more accurate one. So it will be roughly very close to 269. Make sure that you look it up. You can Google it too. You can just say t-star degree freedom 48, 99%, and it will tell you what it is. The C question, calculate the confidence interval. Do not interpret the answer. So, but we will still interpret the answer, but for now, we're going to do the confidence interval. Confidence interval for this chapter is y bar plus or minus t star standard error. Your average provided in the question is 22.5. Your t-star, we're going to use 2.69. And your SE, we calculated 0.6. So it's 22.5 plus or minus 2.69.6, and that's 1.614. So you minus them, you add them. When you minus, it'll take you down to 20,885. you add them, it'll take you to 24,115. Tells you not to interpret the confidence interval, but I'm still gonna do it. So first of all, assumptions. At this point of the game, did we check the assumptions? Or did they mention in the question that the assumptions met? No. We didn't check, and in the question they didn't say anything about the assumptions, so you say since, F. If the assumptions met, you say since. So here we don't know anything about the assumptions, so we say if assumptions hold. This is a 99%, so you say we are 99% confident that population mean, and you go to the question, the mean provided is what? That's the average age for first time marrying or first time marriage for women. So population mean, age of first time marriage for the population of all women. And did they mention a city or time? Did they say that this is in a certain city or in a certain time? No, so we just say population of all women. And this, it's better to say in this particular city or town or place. The things that I underlined are the only things that change when you do a confidence interval. Everything else is the same. So just the confidence level changes, and whatever the mean is, mean of what, that changes, and what the sample is. And usually the mean, it's good to say the unit measurement. So it's age in bracket in years, because everything was measured in years. Okay, so we're good. We're going to go to the next part. Discuss the assumptions. So now they want us to discuss the assumptions. That's part D. First assumption is randomization, also called independence. The sample of 49 women must be selected randomly. And if you go to the question, it's not mentioned in the question. So you say the sample of women was not selected randomly, not mentioned in the question. So sometimes we say, but it's safe to assume randomization. In this question, I don't see a reason to say this, so we say condition not met. Condition 2, normal population assumption. In order for us to analyze or discuss this condition, you need to have a histogram or a normal probability plot. If you're given a histogram and it looks like this, then it's normal. If it looks more like this, then it's right skewed. And if it's the opposite way, this is left skewed. If it's the opposite way, it'd be right skewed. But you notice that nothing is given. And in the question again, there was no mention of normal or being normally distributed. So you say, no histogram, no normal plot probability given, cannot assess condition. In this case, sample size assumption must be checked. So we have to check the sample size now. Sample size assumption in the sample size assumption, your n is 48. That's more than or equal 45. So you have a large sample. So data could be skewed with gaps and outliers, and it doesn't matter. So they could be skewed with gaps and outlier. Because large sample, we're safe. We don't have to worry about it. So you say, therefore, condition is met. Okay. Now, in each chapter, it is possible to ask you the question, confidence interval, like this one. It's also possible that they ask you the question based on, or ask you a hypothesis. So in this chapter, which is one sample average or one mean, they could ask you the same question, hypothesis. Something like at 5%, is there evidence that mean age for women is more than 20? So a typical question would be state hypothesis, and define parameter. So H0, HA. Then this chapter, it's one sample mean. So here we say mu equals whatever the number is. And since we're testing for more, we say, or it could be more than the number. That makes it a one-tail analysis. Then they could ask you to find t-test and p-value. These would be provided most likely if they ask you this question in the midterm. These will be provided Minitab. But I don't have the Minitab for this question, so we'll do it. For the t-test, we follow this formula. Y bar minus mu over the standard error. Y bar is 22.5, mu is 20, and this one is 0.6. Your t would be 4.1667. And to get the p-value, we need to get it from the t-table. To get it from the t-table, you need to know DTT. Degrees of freedom, test, tail. Degree of freedom, we knew it's n minus 1, so it would be 48. Test number is 4.1667. And we mentioned here that it's one tail. Again, I think that if they ask you the hypothesis question, Minitab, you'll see the p-value and the test and the Minitab. But if you have to do it, you have to use the table. So you go to the table, you go to the degree freedom 48. I don't have 48, so I'm gonna use 50. And in this line 50, I look for this number. I don't see it because it's more than this. The last number is 3.46. I'm more than this, so I go up to the one-tail percentage. Anytime the number becomes larger, percentage becomes smaller. So I must be, p-value must be less than 0.005. It's a very, very small p-value, almost 0%. And then finally, you talk about the conclusion. Before I talk the conclusion, I forgot to define the parameter. So to define the parameter, you say let mu be population mean, age of first marriage,